Okay, can you hear me?
Hello.
Can you hear me now? Yeah.
Yeah, thank you.
Okay, just we are waiting 1 minute. Then we'll start today's session for joining all of other participants.
Okay.
Okay, so we'll start. I think other participants are not joining for their region. So we will start. Okay, and they can easily cover this part using the recorded class also, no problem. Okay. Okay, so basically, today we talk about the second number of days content on Google Earth Engine. So let me share my screen. Okay, can you see my screen now?
Yes, sir.
Oh, let's. So basically, today's session I will try to discuss about that how we can easily filtering and displaying the satellite images, mainly Landsat, Sentinel, MODIS. So this type of satellite imagery, how we can easily filter and display. As well as we talk about that satellite composite, how we can easily create the different types of composite, such as median composite, mosaic composite. So these type of things, how we can easily create in Google Earth Engine. We also talk about that. We also talk about that band combination, how we can easily use the different types of band combination, false color composite or false color band composite, true color band composite. So this type of combination, how we can easily create, we also talk about that, and how we can easily export the satellite imagery, mainly Landsat, Sentinel, MODIS. So this type of satellite imagery we can easily export from the Google Earth Engine, and further we also work with that other software also. And we also talk about that import, filter, reduce, clip, and display the raster data in Google Earth Engine. We also talk about the time series chart of NDVI or any other indices, how we can easily create the time series chart using the ready-made dataset. We can also talk about that, and how we can easily export the any shape file, as well as we also talk about that annual image composite. Suppose Landsat for annual image composite for 2000, 2010, or 1990, 1991, 1993. This type of annual composite, how we can really create. Okay, And after completing the live training session, then I also discuss about your problem solving class for 1 hour. So 3 hours mainly our live training and 1 hours for your problem solving. In the problem solving, you can easily share your skill, then you can easily get that solution about your problem for regarding for previous class topic. Okay, so let me share my slide. Okay, so we already discussed about that Art Engine public data catalog. So basically in this public data catalog, we can easily access all of satellite imagery. It can be Landsat, it can be Sentinel, it can be MODIS, it can be CHARPS, it can be Aster. So all of satellite imagery, we can easily access from the Art Engine public data catalog. And when you want to use the Google Earth Engine platform, this is the best benefit to get all of data without storing. All of data we can easily get from that cloud-based or Earth Engine public data catalog. We can easily access Landsat, Sentinel, MODIS, Train, Nancover, atmospheric data. There are a lot of data set are available in the Google Earth Engine public data catalog. More than 200 public data set, more than 4,000 new images every single day we can get from here, more than 5 million images and more than 5 petabytes of data we can easily find out in the Earth Engine public data catalog. And this is the link about that Art Engine public data catalog. Simply you can go to this link, then you can get all of data set. Okay, so and further in this time we talk about that how we can easily filtering and visualizing the satellite images in Google Earth Engine. So basically when you filter satellite images in Google Earth Engine, it depends on the three factor. Okay, first factor is your region of interest. Which region you want to need this image? So this is the one factor for filtering. Suppose I need the image for the Dhaka city boundary. So my region of interest is Dhaka city. So I need the satellite image for the Dhaka city. So it's one kind of factor for filtering. Second factor, it called the image metadata. Suppose you need only for this image, which image will be not more than 1% cloud cover. It's the filtering image properties for specific properties, suppose cloud cover. You need only for this image, which image will be not more than 1% cloud cover. So this is the second factor for filtering. And third factor, mainly the specific time period. Suppose you need the imagery for year of 2017, month of January. You need the image year of 2017, annual summer season, rainy season, or different time period. Okay, so when you filter any image collection, basically it depends on three factors. First factor, it's mainly your region of interest. Second factor, it's filtering the image metadata. Suppose you need the image only for the less than 1% cloud cover. And third factor, it's mainly for a specific time period. So using these three factor, all time we filter our image collection all time. So now let's check the practical example. It's more better. So let me open my code editor. Okay, so here you can see this is the search place and data set. I just click the browse data catalog, then it will be open all of data set. We can easily find out all of Art Engine public data catalog. So further, we can easily use this type of data. So you can see the Landsat, Modis, Sentinel. So all of data, so we can easily access from the Art Engine public data catalog. You can see the search bar and you can click on the browse data catalog. Then you can get all of data set. So now I want to work, suppose Landsat, click on the Landsat. So now I can get all of Landsat image collection for different time period. So here you can see, this is the Landsat 9. It's available from 2021 to present time. This is the Landsat 8. This data set is available from 2013 to present time. This is the Landsat ETM Plus sensor. We can get the image 1999 to 2021. Also, you can see about that Landsat 5. It's available from 1984 to 2012. Also, Landsat 4 TM. It's available from 1982 to 1993. And Landsat 1 to 5 MSS sensor. We can get that 1972 to 1989. So all of Landsat image collection for different time period we can easily get from here. And when you filter this type of image collection, all time we just apply the same approach. Suppose you filtered the Landsat 9, you have to use the same approach for the Landsat 8 or Landsat 7. We are just following the same approach when you filter any kind of Landsat image collection. So let me show the one example for Landsat 8. Click on here. Now I can get all of Landsat image collection. Basically, we can get the three types of reflectance. One is that raw image. It's the raw image. This is the top of atmosphere reflectance. This is the surface reflectance. Okay, and this is the raw image. So top of atmosphere, surface reflectance, or raw image, when you filter, we have to use the same approach all time. So basically, the surface reflectance we are used for that, making the land use and land cover mapping, as well as also making the land surface temperature mapping. We are just using the surface reflectance data. And top of atmospheric, mainly useful for making the water quality monitoring using the indices or NDVI, NEWI, or any kind of indices. We can get the more better result using the top of atmosphere sensor. So this is the raw image. Basically, from this raw image, it created the top of atmosphere and so created the surface reflectance. So here you can see this surface reflectance is the atmospherically corrected. Okay, so this data set is already done for atmospheric correction, as well as also you can see this data set is also atmosphere reflectance calibrated top of atmosphere. So this data set is also done, all of correction also done. Okay, so in this time when I use this type of imagery, we don't need to put any kind of correction such as atmospheric correction or enhancement. So this type of things we don't need when I use this type of imagery, top of atmosphere or surface reflectance. Okay, suppose in this time I will show you the example for top of atmosphere. Just click on here. So now I can get all of details about that Landsat 8 top of atmosphere reflectance dataset information. The first information you can check about that dataset availability. We can get the dataset. It will be start from year of 2013, 0318, and last time period you can see 2024, 8 June. Okay, so this is the last time period about this dataset, and this dataset is also updating. Okay, automatically updated when new images come, automatically updated in our dataset. And this is the dataset provider. So basically, this provider is that USGS, mainly Earth Explorer, and also Google. They also provide this data. And further, this is the snippet, Art Engine snippet. Snippet mainly it's one kind of unique ID. Okay, so every image collection or every data set, we find this type of snippet. Okay, snippet is one kind of unique ID of this data set. So here you can see this is the name about that Landsat, then 8. Okay, you can see T1 and top of atmosphere. Okay, so this is the unique ID about this data set. Okay, so every image collection we can find out this type of unique ID. Okay, Also you can see about the description about this image. Here you can see, so basically you can see it show about that all of description, as well as click on the bands, then we can get all of bands. So basically B1 is the coastal aerosol band, B2, B3, then blue, green, red, near infrared, short wave infrared 1, short wave infrared 2, okay, pancometric band. So all of band we can easily find out from here. You can check about their pixel size, also get about that wavelength. Okay, so this is the information, as well as we also get the image properties. Mainly it's called the image metadata. We find out the different types of image properties. You can see cloud cover land, lot of image properties we can get from here. Okay, also you can see about the terms of use. So in this time, this is my data set. This data set I want to import in my code editor. So this is my code editor. Okay, and this is my data set. So this data set I want to import in my code editor. So how I can import? We can follow the two way. One way is that you can simply search here. Suppose you can simply search here your data set. Simply search here Lancet 8 TOA or top of atmospheric data set. So here you can we can get all of Lancet data set look like that. Lancet 8, Lancet 9, Lancet 7. Suppose Lancet 8 top or I simply click on here. Then I can get all of information about this data set. Okay, you can see description, band, image properties, or term of use. Okay, just simply click on the import button. Click the import button. We can easily import it, this image collection. Okay, so this image collection is easily imported. You can simply search here and then find out your image and then click on the import. Then this image collection is imported in my code editor. So it's one way for importing the image collection. Another way is that you can simply copy. Suppose I simply copy this snippet or unique ID, simply copy this unique ID and then paste here. Okay, then give a variable name. Before the variable name, must use here the var keyword and put the variable name. You can put any name. You can put any name as a variable. Suppose I put the name is that L8 and equal sign. Okay, so this is the another way. So one way you can simply search the data set and then import from here, or another you can simply copy the snippet or unique ID, then paste on your code editor, then give a variable name. Okay, so this is the two way when you import your data set, any data set in Google Earth Engine code editor for any time. Just simply copy the snippet ID of your data set and paste and then give a variable name. Okay, and set when you import, just use the same approach for importing. Just simply copy the snippet or search the data set from here and then import from here. Okay, so I hope you can get this idea. And here you can see it show about the image collection. So basically it's the default variable name. It show about the default variable name as the image collection. You can easily change it, any name. You can put any name, suppose L8 or any name you can put. There is no problem. So it's the default variable name in the image collection. Suppose I simply remove that, it not need. Okay, this is the another way I follow. Just I simply copy the artisan snippet and then give a variable name. Okay, so now this full image collection, mainly Lancet 8 top of atmospheric image collection, is stored in my variable. Okay, it is stored in my variable. So now let's check how many images are available in this collection. I want to check how many image collection, how many images are available in this image collection. For doing this thing, just simply use here the print function and call the variable L8, because this L8 is stored this full image collection. Okay, I use a function, it's called the size function. Okay, size function mainly computing how many images are available in a collection. So just click to the run. Now we can get how many image collection are available. So now it's computing this images, how many images. Okay, so here you can see we can get that more than 1 million images are available in this image collection. You can see it's very, and it's show for the whole world. Okay, whole world between this time period, year of 2013 to 2024. Okay, so whole time period for the whole world, we find out this number of images are available. Okay, so now this number of images I need to filter. And we already know about that how we can filter. Mainly three factors. One factor is the region of interest. Second factor, filtering image metadata. Third factor is that image specific time period. Okay. So now try to find out one by one. So this result show for the whole world. But in this time, I don't need for the whole world. I need only for the region of interest. Suppose Dhaka city. Just I simply imported the Dhaka city boundary shape file. I already import the Dhaka city shape file in my asset tab, and I already show you that how we can easily import it, the shape file. So this shape file, I simply click on the import. Okay, and I put the. Okay, can you hear me? Hello.
Yes, sir. Yes, sir. Now
Okay,
we
okay.
can hear.
Suddenly electric is the one. Okay, so now correcting. Yeah. Okay, so now here you can see we can get this large number of image collection. It's available for the whole world, but in this time I don't need for the whole world. I need only for the region of interest, Dhaka city. I just simply import my shape file of Dhaka city, and it's give the name as a ROI. Okay, so okay, okay, so here you can see about that we get okay, so that's perfect. Yeah, yes. Okay, so this is our full number of image collection. It is stored in this variable L8 for the whole world. But in this time, I need only for my region of interest, Dhaka city. So just I simply copy the L8 and then use a function. It's called the filter bounce function. Okay, so mainly filter bounce function is intersecting your full image collection with the region of interest. Okay, and you can check about the argument. We can get the argument is a geometry. Geometry mainly it's your shapefile variable name. Okay, so in this time my shapefile is the Dhaka city, and I already give the name as a ROI. So just I put here that ROI. So now what happened, you can see this is my full number of image collection. In this time I use a function filter bounce function, and I put my boundary, mainly my shapefile boundary. It is stored in the ROI. So just I put here the ROI. So now let's check how many images are available in my region of interest. So just simply print again. So print and call the filter region and use the size function. How many images are available in my region of interest? I want to check it. So now let's check again. So now we find out that 447 images are available in my study area. Okay, 447 images are available in the region of interest in Dhaka city. And what is the time period? This time period is that year of 2013 to 2024. Whole time period. We find out the image total 447 for my region of interest in Dhaka city boundary. Okay, so now from 447 images, I need only for those images which image will be not more than 1% cloud cover. I want to filter only for those images which image will be not more than 1% cloud cover. So in this time we filter the image metadata. Suppose I find out the 447 images, but from 447 images I need only those images which is less than 1% cloud cover. Less than 1% cloud cover. Okay, so now we filtered the image metadata. 447 images from, we just choose only for the less than 1% cloud cover. So just take a variable, suppose filter metadata. You can put any name as a variable. These 447 images already stored in a variable. What's the variable name? Filter region. I simply copy the filter region. Simply copy and paste here. Okay, then I use a function. It's called the filter metadata. Okay, filter metadata, it's one function. This function mainly filtering the image metadata. or image properties, it filter. You check what's the argument about that. You can check, we find out the argument. One is the name, then operator and value. Name mainly image properties name. Here you can see in the image properties, we find out the lot of image properties name. Cloud cover land. Suppose I use the cloud cover. I simply copy the cloud cover and paste the cloud cover name in here. And operator, I choose the operator, suppose less than 1%. So put here the less than and set the value for 1. Okay. So now what happened? Filter region, this variable stored the 447 images. From 447 images, I choose only for this image, which image will be not more than 1% cloud cover. So now let's check how many images are available, which is the less than 1% cloud cover. So just simply print function again, filter metadata and paste here, and use the size function for computing how much images are available in this collection. So now we find out that how many images is the available less than 1%. We find out the 67 images. So 67 images are available. These images are the less than 1% cloud cover. Okay. And what is the time period about that? This time period is that from year of 2013 to 2024. From 2013 to 2024, we find out total 67 images is the less than 1% cloud cover. Okay. But in this time, I need only for the specific time, not for the whole time period. Suppose I need the image. I need the image year of 2023. Okay, not whole time period. I need the image only for year of 2023 from 60 images. So for that, I just take a variable. Suppose filter date. And now I call the filter metadata because this filter metadata is stored at the 67 images. From 67 images, I choose only for those images which images are available in year of 2023. So just I simply copy the filter metadata again and paste here, and then use the function. It's called the filter date function. Okay. So filter date function mainly filtering the date, your specific time period. So just I put here the start date and end date. Suppose I put the start date year of 2023, 1st January, from year of 2023, December 31. So 1 year of 2023. So now let's check how many images are available in year of 2023. Just print again the filter date and use the size function. Just put here the size. So now let's check how many images are available year of 2023. We find out only for the 7 images. Okay, so this is our filtering. So first of all, I find out that very large number of image collection for the whole world, but I don't need for the whole world. I need only for my region of interest in Dhaka city. I find out 447 images. I don't need all of images. I need only for those images which image is the less than 1% cloud cover. I find out 66 images is available, which is the less than 1% available. And I don't need for the all of whole year. I need the image only for year of 2023. So here I find out only for that 7 images are available. Okay. So can you get the understanding about that? You can see here, first of all, this is the image collection. How many images we can get? We can get, you can see very large number of image collection in here. Okay. And further, I need only for the Dhaka city image collection, we find out 447 images. Okay. We just filtering this image collection. From 447 images, we choose only which image is the less than 1% cloud cover. We find out 67 images is less than 1% cloud cover. From 67 images, we choose only for those images which images are available year of 2023. So we find out that 7 images are available in the year of 2023. So now what is the characteristics of these 7 images? This 7 image is the less than 1% cloud cover. These 7 images are available between this time period. This 7 images is available in my region of interest in Dhaka city. Okay, so first of all, here you can see, first it's called the filter bounds function. So basically it means that where you need this image, mainly your study area, your shapefile boundary. Then another is that filter metadata. So basically it means that filter metadata means that how I need this image, mainly less than 1% or less than 2% or less than 3%, we define in here. Some region such as coastal area or riverbank, you don't find out that 1% image, then we have to increase the cloud cover level. Suppose in the coastal area you check the less than 1% image is not available, so for that you have to increase the value of the cloud cover value, we need to increase, then we find out the image. Okay, and also you can see about that this is the filter date, basically when you need this image. Okay, when you need this image for a specific time period. So for the filtering we are just use at the where, then how and when. For the where we are just use a function, filter bounds function, and then how we use the filter metadata function, and when we use the filter date function. Take all of image information. Suppose this total 7 image information I want to check. So for that, just print this filter date variable, simply copy the variable and paste here, click the run. So now we get all of information about these 7 images. So let me open. So here you can see total 7 element. It means that it has total 7 images. So just click on here, then further we can get about that. You can see about the type. Type is the image collection because it has the more than one image. Okay, more than one image, it means a collection. So it's a total 7 images. So that's why this type show as the image collection. Then this is the ID, basically image ID we can get, and you can see about the band. So all of images have this type of band, B1, B2, B3, all of them is available in here. Also you can get the feature. So in this time here we can get the total 7 feature. It means that it has total 7 images. So you can check about the time. So here you can see the first image. This acquisition time is that year of 2023, 18 January, 7 March, 8 April, 2 November, 3rd February, 8 April, 2 November. So here we can get also their acquisition time, all of images. Total 7 images, all of acquisition time you can also get from here. Not only for that, if you want, you can also check it. Suppose click on here, then click on the properties, then we can get all of information about the images such as cloud cover 0.1, cloud cover land 0.1, collection category T1. So all of information you can easily get from here. You can see about that data acquisition time, we can get look like that time here. You can see also you can see about that datum WGS 84. So all of you can see the Earth Sun's distance. So all of information about this image we can easily get from here. Okay, you can see there's a lot of information. Mainly it's one kind of image properties or image properties information we can easily get from here for a specific image. Okay, suppose you get this as second image. For the second image we can get this type of things, all of information. So now let's check the visualization. Suppose this second image you can see year of 2023, 7 March. This image I want to visualize on my map. So what can I do? So it's called the single image visualization. Just we are add this image. So just I simply copy this ID for this second image, which is capture year of 2023, 7 March. Okay, I simply copy this ID. After copy this ID, it's an image. Okay, not image collection. So for that, I take a variable. Suppose variable name is the image. You can put any name as a variable and use it ee.image. Okay, because you can see it's only for the single image, not image collection. And then paste here this ID. Okay, so basically this ID is stored only for the single image, which capture in year of 2023 7 March. Okay, so now let's check about the image. I want to add a layer of this image. So just use the same function map.add_layer. We already discussed about that. And then copy the variable name and paste here because I want to visualize this image, and this image is stored in this variable name image. So I want to add a layer. So just use here map.add_layer and click to run. So now you can see it added the layer, but not visualize my study area. So for focusing, we are use a function map.center object. Okay, and I put my object name, suppose ROI. This is my shapefile variable name, and zoom to layer level 10. Click the run. So now it visualize my study area and also show me this image. You can see it look like that. It show as the tiles. Okay, it show as the tiles. You can see it show as the tiles, and which tile cross with my study area we can get. You can see overlay with my study area. So if I add my shape file, suppose map.add_layer of my study area, which is ROI, then it's a more better understand we can get with our study area, as well as you can also get about this tiles. This tiles is overlay with our study area or not, we can easily get. So you can see this is my tiles, and here you can see this type of region is the missing. Okay, you can see this type of region is not captured by satellite image. This tiles which captured in year of 2023 7 March. Okay, so for that what can I do? For that you have to check some other images. It is fill up your study area properly or not. Just simply click on here again and then click on the feature. From the feature, suppose I want to check the another image, suppose third image. Then copy this ID. So here you can see this is the ID. Simply copy this ID and further paste here. Just change it. Just paste here. Okay. Now let's check again what happened. It fill up properly or not. Okay, same. It also not fill up the properly. So we try to check the another image. Suppose I check this image. Just copy this ID and paste it. Now let's check what happened. Okay, it also not fill up, we can see. So let me check the another. Copy this ID and paste here. Click the run. Okay, so now I can see fill up my study area. Okay, it's the properly overlay with my study area. So then I can easily use it this image which captured the year of 2023 048, mainly 8 April. Okay, so now I need the image only for my study area. Just I clip with my study area. So for that use a function, clip function. Just put here the clip with your study area, which is Dhaka city boundary, stored in a variable ROI. Click to the run. So now I got this result only for my study area in Dhaka city. You can see you can get this type of imagery, but it shows as a default color. Okay, so in this time I want to add the different types of band combination and visualize this image. For adding the band combination, you can simply click on here. You can see, click on here and we find out the B1, B2, B3. So I want to add the different types of band combination. Suppose one band combination red, then put here that green and blue. Okay, red, green and blue create the RGB or natural color, mainly what human I can see naturally. So then I just simply custom I stressing this data. Stressing is one kind of data visualization process. Okay, so I put the 98% stressing on my data, and then I want to visualize it. Then apply. So now you can see it show this type of true color composite of my satellite image for my Dhaka city. Here again, so you can get this type of imagery. It's called that natural color. So we can easily find out, you can see the vegetation green color. It's show about that build up or settlement. We can get this type of barren land. Okay. Also you can see about that water body we can get from here. So this is the one kind of imagery we can get for my study area. And it's called the single date image. Okay. Because you can see we are not create any kind of composite. It's just a single date. Suppose some analysis, you also need the single date image. Some analysis, you also need that composite image. And composite is very important because when you want to work with big study area, okay, suppose you want to work for that whole study area of Bangladesh, okay, you need the satellite images. Then one tiles is not enough for covering the whole study area of Bangladesh, or whole study area of India is not enough for the one tiles. So for that, we have to use the composite, mosaic or median composite. So here you can see one kind of example. I will show you that. Suppose I simply search here. So here you can see, suppose for Bangladesh, whole country boundary of Bangladesh, you can see, we can, okay, just I open this imagery. So here you can see there are a lot of tiles, 1, 2, 3, 4, 5, 6, 7, 8. So one tiles is not enough for the whole study area, is not enough. We have to use, you can see, I just open the imagery. Yeah. So here you can see in this time, when you want to work for the Bangladesh whole country boundary, so we need okay. So one tiles is not enough. One tiles is not enough. So for that, we use the composite to create the median composite or mosaic composite for the big study area. Okay, then we can easily get the whole boundary area satellite imagery. But in this time, for the small area, such as in a specific boundary, a small boundary, we can easily get that single date imagery. Okay, we can easily show the single date imagery, and further we can use this imagery for using the land use, land cover, or NDVI, or crop classification, or any other remote sensing tags. So it's called the single date image collection. But if you want, you can also create that composite. Suppose in this time, here I got total 7 images. Okay, this 7 images I want to use and create the composite. So how I can create the composite? For creating the composite, just take a variable. Suppose I put the variable name is that final image. And this image, I use all of images, all of 7 images. So just I simply copy the filter date and paste here and use a function median composite. Median. So what is the median composite? Basically, median composite in this time take all of middle pixel value from total 7 images and create this composite. Okay, take all of images. In this time filter date, it distorted total 7 images. So I want to create the total 7 images median composite. So just I simply call the filter date and use here the median function. And further, okay, I will show the result first. Suppose I just click the map.add layer and call the final image. I want to show, just paste here. So now in this time, total 7 tiles. For the different time, total 7 tiles. Just create the median composite. You can see we can get this type of imagery for the Dhaka city. All of images, mainly total 7 images. So here you can see. So in this time, it create this type of things. So all of imagery combine to their middle pixel value and create this type of composite. Okay, so it looks very large area. So further, you can simply clip with that. So we can just clip with that. So clip with my shape file, which is ROI. So now click to the run. It's the area. Band 3, band 2, custom stressing 98%, and further apply. So now you can get this type of imagery. You can see. Now you just click on the import button. Import mainly its visualization parameter. This visualization parameter I just simply import in our code editor. Just click to the import. You can see a new line of code added. Simply copy this variable name and further put. Suppose I just put here. Okay, and also put the layer name. Suppose I put the layer name is that median composite. Click to the run. So now we can check the visualization will be set it with our one layer. Here you can see it's set it with our one layer. So here you can see this is our median composite which I set in here. Okay, it show about that median composite. Median composite mainly it consider total 7 images middle pixel value and create this composite and store it in this variable. And also you can say about the single date. So basically it's only for the single date imagery. So this is the layer about that single date imagery. This is the layer single date imagery. So I also want to add the visualization about the single date imagery. So for that, just click on here again. Just click on here again. Suppose I want to show the another band combination, false color band combination, which is the near infrared. Then put here that red and put here that blue. It's suppose the stretching 98% I put. And further I apply. So now it also create this type of image. You can see you can get this type of band combination, linear infrared, red and blue. So now we can get this type of things. And this visualization I want to import in my code editor. Just simply click on the import button. You can see new line of code added. Simply copy this variable name and paste after the object name. So this is my single imagery. I just put here object name and I put the layer name. Suppose I put the layer name, suppose single date. Click to the run. So now I can get this type of things here. You can see we can create the total 3 layer. First layer is the median composite. Second layer is that only for that you can see about that study area or boundary. Okay, and you can see this is the one layer for the median composite. Another is the single date which I created, the another band combination about that. Okay, so here you can see this is the process about the single date, how we can easily show for any single date imagery for the specific study area after filtering, and also create the composite, mainly median composite. And it's very important for that your big study area, suppose whole country boundary of Bangladesh, whole country boundary of India, when you want to use, then you can simply put here that filter bounds function and work with that. So here again, so you can get this type of result, look like that. Okay, so anyone any question about that, you can ask me for this time. Any question?
Hi, sir.
Yeah, please.
Yeah, so like I would like to know why do we use the stretch at the 98%? Why not the other percentages?
Which one?
Like stretch.
Okay.
Image stretch in the image visualization parameters.
Okay. So I understand. Yeah. So stressing. So basically stressing is one kind of data visualization process, and if you want you can also use the other stressing also. Suppose here you can see when I put at the stressing 90%, and we can it also change the range, mainly wavelength range, then we can get this type of visualization about our imagery. You can see we can get this type of visualization when I put this type of stressing. Suppose when I put at the stress 3 sigma, you can see it also change about that, and click the apply. So now we can get this type of visualization about this imagery. So basically this type of stressing, it one kind of visualization process. Maximum time we find out that 98% it show the more better visualization than 90 or 100 or 3 sigma or 2 sigma or 1 sigma stress. So we find out that more better result in the 98%. Okay, so you can see when I apply that, then this image is also more better than other. Okay, so basically it's different on you. So basically it's the one kind of stressing. When I put the stressing, it automatically change the mean and max value. Okay, and find out that value which is the use for better visualization about that. So basically 98% is better, so that's why we are also use the 90%, 98%. Some map or some work we also use at the 90% or 3 sigma. So basically it's different on our visualization process. Okay, basically it automatically changes. Mainly this range will be changed. When I put at the 3 sigma, you can see it automatically change about the range. So now it is stressing with this range and get the visualization. So apply. So now I can get this type of visualization in here. Okay, and when the visualization is import, just simply click on the import. Further, copy this variable name and paste after the layer variable name. Okay, you can see this is the variable name. This is my layer object name, and I put at the visualization variable name and put the layer name serially. We put in here object visualization parameter and name. Okay. Okay. So now in this time here you can see I use that for variable filter bounds function. I just take a new variable. Filter metadata function, I also take the another variable. Also you can see about that filter date function, I also take the another variable. So every individual function I just take the different variable. But if you want, you can just take only one variable, and using this variable you can put all of argument. Okay, you can put all of argument in here. So for that I show you this process in this time. So just I simply comment all of line together. In this time I just take only one variable. Suppose I just put only one variable for L8. Suppose L8, this is my variable, and I want to all of things I want to add under the L8 variable. So first of all, for that just spaces doesn't matter. Suppose you can write the code in here, also write in here, there is no problem. Spaces doesn't matter in JavaScript programming. Okay, suppose I just simply write the second function in here, filter bounds. Filter bounds mainly intersecting with your study area, which is RY, mainly boundary shape file. Then I put it the suppose filter metadata. Mainly it's filtering the specific properties of your image collection. Suppose I need the cloud cover, so just put here the cloud cover and put here that less than. Suppose I put the less than 1. Okay, and further I just put here the filter date function. I just put here the start date and end date. Suppose year of 2023, 1st January, or any time period you can put in here. Then year of 2023, December 31. So now let's check how many images are available. Final product, you can see. Just call the L8 and use the size function. So click to the run. So now it's computing how many images are available. We can get only for the 7 images. Okay, so you can see here, suppose filtering process. So just I simply commenting this line, also commenting this line. So now we can get the image only for the Dhaka city area. How much images are available? 447 images are available in the Dhaka city study area. And then I need only for those images, which image is the less than 1% cloud cover. You can see how much image. We can get that 67 images are available in the Dhaka city, which is the less than 1% cloud cover. And from the 67 images, how much image available for the 2023 January December? We can check it. Just click the run. We find out the 7 images. Okay, and you can see we can get the 7 images. Further, you can check about that print and your 7 images. Okay, further you want to work for the single image, then simply click on the feature and copy your single image id. Okay, copy your single image id. Suppose I work for this
Oh, sir, your audio is muted, I think.
okay, thank you, just a minute. Okay, now can you hear me?
Yep. Now you can.
Let me share. Okay, so here you can see we can get this type of things here. So we can get that how many images, we can get the, all of information. Further, you want to work with the single imagery, just simply copy this ID. Okay, copy this ID and then this ID take a variable, suppose image, and put here ee.image and put this ID. Okay, further you display this result with your study area. Same process for single date. Suppose I just show the result map.add layer and call this image. So click the run. So we can get this time imagery as a tiles. We find out in here, you can see. Okay, if this tiles is not cover your study area, then further you try to check the other image, other single date imagery. Okay, or if you want, you can directly create the median composite. For the median composite, what we can do, just we take a variable, suppose median composite. You can put any variable name and call this L8 because it is stored total 7 images, and all of images I want to use for create the median composite. Just put the L8 and put here the median function for creating the median composite, and further clip with your study area, which is ROI. So now let's visualize this imagery, map.add layer, and call the median composite. Click the run. So now you can get this image for our study area easily. We can get it. It look like that because I don't add any kind of visualization. So further simply click on here and then put at that B4, B3, B2, RGB. Suppose put the 98% stress. Then it show about that mean and max wavelength value. Then apply. So now we can get this type of imagery, look like that. And this visualization I want to import in my code editor. Further, simply click on the import button. Suppose copy these things. And further, I just add after the layer variable name. So this is my object. After that, I put here the visualization variable name. And then we put here that layer name. Suppose I put the layer name is that imagery, or you can put any name. Click the run. So now it creates this type of things. Suppose you want to create the other band combination, such that suppose I click on here again and I create suppose false color, put here the B5, near infrared, red and blue, custom stressing 98%, and further I just apply. Then we can get that false color composite. So in the false color composite, you can find out the vegetation as a red color, water body show as a black color. Okay, we can get this type of feature from here. Okay, just I import these things and I want to add a layer about that. So further I simply copy the same code, copy, just change the variable name. Okay, so here you can see I simply copy that and then further change the visualization variable name. Okay, I put the layer name, suppose it's a false color. Click the run. So now you can see it added the two layer. one layer display the result for true color composite, another layer display show that for false color composite. Okay, suppose I add the more other combination. Click on here again. Suppose I just add here that combination is called that short wave infrared 1, which is B6, and put at the near infrared B5, and put at the suppose green, and further construction 98%. So now we can get that another band combination look like that, and very useful for critical. Need about that. Okay, so just I simply import this band combination, import, further copy this variable name. Okay, simply copy.
Sir, again we lost your audio.
Okay, I don't know what is the problem. Yeah, just a minute. Okay, let me share my screen. Okay, now can you hear me?
Yes, sir. Now we can hear.
Okay. So now you can get this type of things. Here you can see this is the band combination is very important for identify that agricultural land or crop land or vegetation. We can easily identify. So just simply import, then it will be imported. And I want to add the layer about that. So for that, copy. And I simply I put the variable is, and I also put the layer name. Suppose you can put any name as the layer name. Click to the run. So now you can get the 3 layer with their 3 different visualization. There again, so you can get this type of things. One is that this type of layer. Then we can get false color combination and get the true color combination about that. Okay, so this is the process for filtering your image collection and visualize. Okay, so first of all we have to use a function. It's called the filter bounds function. Okay, filter bounds function mainly intersecting with your image collection. Okay, filter bounds. So this image collection is the full image collection. Where I need this image, basically it's identify about the where you need this image. You need this image for your study area, in this time ROI, because my shapefile is stored in the ROI. Then second argument, it's called the filter metadata, mainly how you need this image. How, suppose I need this image less than 1% cloud cover. And then third argument, it's called that filter date. It means that when you need this image. So basically where, how, when, using these 3 condition or 3 factor, all time we filter our image collection. It can be Landsat or it can be Sentinel. After filtering the image collection, we are just create the composite. It can be median composite, or we can also show the single date imagery. Another is that you can see single date imagery. Okay, so this is the way for that single date. Sometimes single date image also need, sometimes you need the composite imagery you also need. So further we also try to learn all of those things one by one. Okay, so this is the process about that. Not only for that, we can also export this satellite imagery in Google Earth Engine platform. So let's talk about that, how we can easily export this satellite imagery. And further we also use the other types of software, ArcMap or QGIS software. We can easily show this type of things. So before that, we also discuss about the another topic. Let me open my new code editor. So in this time, we talk about that how we can easily create, mainly import, filter, clip, and reduce the any data. Basically, in this time we talk about this topic: import, then filter, then reduce, then clip any data set in GE. Okay, so import, filter, reduce, clip any data set. So in this time I show the example one. Suppose I simply go to that catalog, just I click on the modis. So in this time we can get that lot of modis data. So here you can see some data set are represented: the trap, vegetation, continuous field, yearly global 250 meter. Also you can see about that there's a lot of data set. Land cover data. Also you can find out that land cover dynamic yearly data set, leaf area index data. Also you can see about the surface radiation data, photosynthetical data, land surface BRF daily data. So there's a lot of data is available in here. Okay, also you can see the land surface temperature data, 8-day global 250 resolution about that. Also you can see the vegetation indices 60-day global data set. Also you can see about that there's a lot of data set is available for that. Okay, so in this time basically all of data, when you filter and create the map, you have to use the same process all time. We have to just follow the same process for filtering and creating this type of data. So first of all, suppose I will show you the example one data set. Suppose I want to work for that this data set I want to use. Suppose it's one kind of data. It's a vegetation indices data, 60-day global, 250 meter resolution. So now I want to use this data, and further I will show you that how we can easily create the map. So let's go. Just I simply click on here. Then it show you that all of information about this data. So basically you can see this data set is available between this time period, year of 2002, 2024, 0524. We can get this data between this time period. Okay, and you can see this is the data set provider. Okay, also again this is the unique ID. This is the unique ID of this data set. Okay, and this data set, mainly how they create this data set, here you can see. So basically this is the description about this data set. This dataset product provides a vegetation index value at per pixel basis. We can get it. And this mode is NDVI and EVI. Mainly it provides the two product. One is the NDVI, normalized difference vegetation index. Another is the enhanced vegetation index. And this data set is atmospherically corrected by directional surface reflectance, have been masked for water, cloud, heavy aerosol, and cloud shadow. So when you use this data set, then cloud, heavy aerosol, cloud shadow, or other unnecessary pixel don't disturb you. Okay, we can get clearly NDVI map when you use this data set, because you can see this data set is already atmospherically corrected. And it already masked for water, cloud, heavy aerosol, or cloud shadow. So that's why you can get that very beautiful map using this data set. So this data set, first of all, I need to import. So how I can import? I simply copy. Just simply copy this ID and then paste here. Okay. Then I give a variable name. Suppose I put the variable name is that any name. I put the name, suppose dataset equal. So now this image collection is stored in this variable. Okay, this image collection is stored in this variable. Now you can see this image collection have a two band. So here you can see the image information. Click on the bands. We find out the two band. One band is the NDVI, another band is the EVI. I want to work for NDVI or EVI, any one band you can choose. Suppose I want to work for the NDVI. So for that, this NDVI band I need to select. So just use a function, select function. Okay, for selecting a specific band NDVI. Okay, so now further I want to check how many images are available in this collection. Just print and call this dataset, copy and paste here. Okay, then use a function, size function. Click to the run. So now it computed how many images are available. We find out 559 images are available for this whole world. Okay, but I want to choose the specific year or a specific time period. So for that, I just use a function filter date function. Okay, suppose I take only for the 1 year data, year of 2023, 1st January from year of 2023, December 31. So this is my time period. So now let's check for this 1 year how much image we can got. So click to run again. So now it show you that for 1 year we find out the total 23 images. Okay, we find out the total 23 images are available for the 1 year. So what is the interval? What is the time interval? Time interval is the 60 days. Because here you can see 23 multiply with the 16, we can get almost 1 year, mainly 368 days. So this time interval is the 16 day. Okay, we can get that time interval 16 day. For the 1 year, we find out the 23 images. And what is the time period? Time period is the 16 day. So you can check it from here also. Your image collection here you can see. In this image collection, they are already said that it's 16-day global 500 meter resolution. Okay, they're already said about that. So now this data set we find out in here, and now I want to visualize this data set. So for visualizing, just we are map dot add layer and call this data set. So now it show the result for the whole world NDVI map year of 2023. Click run. So now I can see it visualize this type of map for the whole world. It show this type of gray color because we not any kind of color. So just we set the color, then we can get the more better idea about the vegetation for the global vegetation. So for doing these things, here you can see they already provide some demo color code. So just I copy the demo color code from here. Basically, it will be start from here, and this is the color code. So just I copy from here. Just copy. Okay. And after copy, just I paste here demo color code in here. Okay. So basically, in this time, they make a dictionary here. You can see and put here the mean and max NDVI value, and also put the some color plated. So just I simply copy these things from here and then paste after the object name. So in this time, this is my object, and I paste here, and I put the layer name, suppose any name. I put the layer name, suppose world NDVI. Click to run. So now it shows the visualization of NDVI map, where we find out that high dense of vegetation, low vegetation, we can easily. So this is the map for world NDVI map year of 2023. This time period, we find out that. Okay, you can see you can get this type of map. I don't need for the whole world. Suppose I need for the specific country or a specific region. So for that, first of all, you have to import your boundary shape file in your asset tab. You can simply import your boundary shape file. Further, we just click with our study area. Then we can get the result for our specific boundary. So in this time, I just use a data set, US DOS data set, which I already discussed. Basically, this data set provide you that international boundary polygon. We can easily get that all of country boundary shape file from this data set it provide. So just I simply import this data set. And then further, I choose my study area. Suppose I just take a variable. I put the variable name, suppose ROI. And now I just call this table. Put here the filter. How I can filter? Earth engine dot filter equal. What's equal what? I put here the country NA. Suppose I put the country name such as Bangladesh. Okay. So now you can see here, just I this variable ROI is stored at the country boundary shape file of Bangladesh. So now further, I just simply take the another variable. Suppose I put the variable name is that NDVI map and call my data set. Here you can see I already make the data set in here. I simply copy the data set. In this time, you can see here, if I put the data set and clip with my study area, which is RY, mainly Bangladesh boundary shapefile stored the RY, and then I want to visualize these things, copy, and click the run. It show a problem. You can see here. It show this is the problem. Dataset.clip is not a function. So it's very important about that. In this time, it show this type of problem. Basically, it's a collection. Here you can see. In this time, it stored the collection 23 image collection, but clip function is only work for image, not image collection. Suppose you have an image, so this image you can just use the clip function, but in this time this data set it stored the collection total 23 image collection, and then I want to apply the clip function. That's why it show the dataset.clip is not a function. So in a collection, I cannot apply the clip function. So you can check the previous example when I use the clip function. In the clip function, I use in here, but before the clip, I create the median composite. Median composite means that it creates the one median composite image from total 7 images. Okay, it creates the single image, single median composite image, which create from total 7 images. Then I can easily apply the clip function. There is no problem. Okay, there is no problem when I use the clip function in here. Also, you can see for the single image, when I use the single image, also there is no problem. So here you can see the single image I put in here. Suppose, yeah. So here you can see the image I put here the clip. There is no problem. But in this time, in a collection, dataset is a collection, and at the same time, in the collection cannot clip with your study area. So for that part we need, for that we need to apply the reducer. So in this time we talk about the reducer. So how I can apply the reducer? I will discuss reducer. So reducer is an statistical function. So using the reducer, we can calculate the mean. We can also calculate that, suppose minimum, maximum, then also standard deviation. Okay, so basically reducer is a statistical function. Using the reducer, we can calculate the average, maximum, minimum, standard deviation. These type of things we can calculate from here. So in this time, this is my data set. It's a collection. So this collection I need to reduce, and then we clip with our study area. So let's check. We just reduce it. For reducing, just I use a function in here, reduce. Then how I can reduce? I need to define in here. I need to reduce reducer dot mean function. Okay. So in this time, this total 23 images create the average result, average image. So using the total 23 images, create the average pixel and create this NDVI map. So these things I can easily clip with my study area, which is RY. So now let's check the result, what happened. You can see now it will work. It will also show about that Bangladesh NDVI map. So just I focus the country boundary shapefile. It also more better. Just put here map.center object. Object is RY. Zoom level suppose 10. Click the run. So now I can get this type of NDVI map for whole country boundary of Bangladesh. Okay, you can see it show this type of map. Not only for the Bangladesh, in this time you can check or any country in the world. Just simply put this country name. Suppose I put here that suppose Pakistan. Click the run. So now it shows about that Pakistan country. What is the NDVI condition in year of 2023? We can easily get it from here. Okay. Yes, you can get this type of map. We can find out for any country. Just put this name. It also shows. Suppose I put here that Niger. Click to the run. Okay, so any country boundary you can put in here. We can easily get this result for any country boundary. Suppose I put here that Australia. Click to run. So now I can get this Australian NDVI map year of 2023. Okay, you can see you can get this type of NDVI map in Australia year of 2023. Okay, so this is the process. And if you have the shape file, suppose you will simply import your boundary shape file in here. Any boundary shape file you can simply put in here. Suppose just I simply import my boundary shape file, and I put the name suppose as a AOI. Okay, and further I simply clip with my AOI. Suppose I just put here the clip with my AOI. Okay, and also focus my AOI. So just put here the AOI, click the run. So now I can get the result which I uploaded in my boundary. Okay, you can see you can get that mangrove forest NDVI result look like that. Okay, so this is the process for creating the NDVI map. But this NDVI map have a problem. Okay, so before that, anyone any question about that, you can ask me. Any question?
Yeah, Bijan sir.
Yeah, please.
Just I thought that that is a 500 meter resolution, no?
Yes, it's 500,
Suppose,
and also available for the 250 meter resolution is also available for the modis. Yeah.
okay. If I need around 2 meter or 2.5 meter, then also we can do it. Huh?
Yes, at least we can get the freely 10 meter resolution imagery in Google Earth Engine platform. It's a Sentinel-2 satellite imagery.
10 meter.
Yeah, we can also use it. Okay, so further we also discuss about the Sentinel also.
Because why I'm asked this means because my study area is a very small area.
Yeah.
If I go through the 500 meter resolution, I can't get the proper results.
Yes, then you can easily use the freely available for the Sentinel-2 satellite imagery. Then you can also get that more better. If you have, you can also buy some high resolution imagery. It can be Maxar or any other sport satellite imagery. Then we also get that more better imagery for the small study area. Okay.
Yeah, Mr. One more thing here. See, suppose I have a data set about 2.5 meter for Cartosat data.
Yeah.
Same data once uploaded, that the same thing we can do it in this.
Yes. Same approach. Suppose in this time we are just applying we can get the Moody's satellite imagery, but when you upload your own data set and your data set have some band or also suppose near infrared band, red band. So further also discuss about that how we can easily calculate. So in this time it's the ready-made data set. Okay. So then I hope you can easily calculate. No problem.
Okay.
So now you can see we can get this type of imagery, but this map have a problem. This problem is that scaling problem. Suppose here you can see when I click on the Inspector tab and click the any portion of the map, then I can get the value of the NDVI. It show the negative value. You can see 132.875. Or click on here, then I can get, you can see this type of value 7,000. But we already know about that NDVI range. You can simply search NDVI range. Then you can get that NDVI range from +1 to -1. This is the range of NDVI. But in this time we don't get this type of result. Okay, it show this type of value. You can see 7,000, or click on here, then you can get that another value. So in this time it show this type of result because it's not reprojected. Okay, this value is not reprojected. So we need to reproject this scaling value. Then we can get the better result. So now how we can scaling this type of things? So here you can see all time we can get the NDVI value between this range. And click on here, then you also get the more better idea about that NDVI. Mainly how it will work, which pixel is identify which feature. So here you can see NDVI values range from +1 to -1. Areas of barren rock, sand, or snow usually show the very low NDVI values, 0.1 or less than 0.1. Sparse vegetation such as shrub, grassland, sensing crops may result in the moderate NDVI values approximately 0.2 to 0.5. And high NDVI values 0.6 to 0.9. It's indicating the dense vegetation. Okay. Also show about the tropical forest or crop at their peak growth stage. We can find out that this type of NDVI value 0.6 to 0.9. Okay. So you also try to read, then you also get that more better idea about that NDVI, mainly remote sensing in the phenology, how you can easily use it. Then you can get the more better idea. Okay. So now in this time, we can get this type of result, which is not reprojected our scale value. So in this time, anyhow, we need to reprojected our scale value so that when I get the result, this result show the range -1 to +1. But in this time, it not show this -1 to +1. So now how I can reproject it, this scale value. For reprojecting the scale value, they are already provide some information. You can see the data set. In this data set, they already provide this type of information. You can see for the scale value 0.001. So it's one kind of scale value. Also you can see 0.01. Okay, for NDVI, EVI is the same scale. So this scale value we have to use in our data set for rescaling. Then we can get the result -1 to +1. This range. So how I can apply this type of scale value? In this time here you can see for applying this type of scale value, mainly we are applying a function technique. Previous class I discussed about the function, mainly how it will be work. So basically function, we already discussed about the function structure. Function structure, mainly we just take a variable name. Suppose I put the variable name is that scaled NDVI. Okay, so in this time, this value, mainly 0.001, this value I need to multiply with my all of images. Okay, this value I need to multiply with my all of images. So how many images I can got? I got total 23 images. Okay, total 23 images we can got between this time. So all of images I want to apply, mainly I need to multiply with my scale factor 0.001. Then we can get the proper range of NDVI. So now how I can multiply at the same time? At the same time, I want to multiply all of images with my scale factor. Okay, so for that, we are applying the function technique. Mainly, we just create a function. This function help me to calculate, mainly multiply all of images with my scale factor 0.001. Then we can get the result. Okay, so now I create the function. I put the function keyword and put the element name, suppose img, image. Okay, and put here my argument. In this time, what is my argument? My argument is that this is image I consider only for the one image. So this is my image. This image I need to multiply with my scale factor. So scale factor mainly 0.001. So for that, I just put here the return. This image is multiply with my scale factor 0.001. Okay, you can see the value. Okay, 0.001. Okay, we have to put the another 0. Okay, so now here you can see I create a function. In this function, I take only for the one element. One element means that one image. This one image I multiply with my scale factor. But I have also other rest of 22 images. So for that, what can I do? Okay, so in this time you can see I just take the one image, one element and multiply with that. But I have also rest of 22 images. For the rest of 22 images, what can I do? For rest of 22 images, we use a function copy properties. Okay, so copy properties, it's one kind of function. Basically, this function copy the properties. Suppose after multiply with this image, it create the properties. These properties I copy. So for that I use here the copy properties function. And this copy properties function I want to apply on my image. And I apply it in my system time start and system time end. So basically here you can see in my system, I already define a time. This is my start time and this is my end time. I already defined the time. So these things I need to apply. This copy these properties and apply system time start and also put here the system time end. Okay, so I can explain this function how I can create. So first of all, you just put the function variable name, then put the function keyword, then put the one element. One element means that one image. So this one image I just simply multiply with my scale factor. But I have also rest of 22 images. For that, I just copy these properties of this image and apply from my system name start and system name end. In this time, system name start and system name end, it means that start time and end time on my system. So this is the function. Okay, this function help you to create the range -1 to +1. But in this time here you can see this function, this is my function and this is my collection, mainly 23 images stored in the dataset variable. Okay, dataset variable is stored at 23 images. So this is the function and this is the collection. There is no connection. You can see there is no connection between the line number 5 number code and from 12 to 15. There is no connection. It totally different. So now I have to make a connection between that function and image collection. This function I created and this is my image collection. So just I need to make a connect these two things. For connecting, I just simply copy the data set and paste here and use a map function. Basically, this map function connecting with my function with my image collection. Okay, so this is my image collection. This including total 23 images. Okay, and this is my function which I created. So this function I need to connect with my image collection. So I call the data set and use the map function and connecting these things. Okay, so do you have any question, any confusion about that? You can ask me, because a lot of time we are also use the function for the different types of remote sensing project further class. Okay, any question you can ask me. For any confusion?
No, sir. Right now, okay.
Okay. So basically further we also a lot of time we also use this concept for the function. So basically in this time we are use the function because at the same time all of images, mainly 23 images, I need to multiply with my scale. So for that just I create a function and this function I connect with my image collection. So this is my image collection. I just and then use the map function. Basically this map function connecting this function with my image collection.